approaching this project, as well as how I apply the principles that I learned in ENME351 to this project. So thank you for tuning in. Okay, so the first thing is at a high level, let me just explain what my project is trying to accomplish. So right here we have an Arduino, and then we have 7 LEDs, and then we also have a servo motor on the side. The whole thing behind this project is there's a user interface for this button, which senses when the user puts in an input, and it will simulate a dice roll, and the dice pattern will show up. Right now it's held at 6, but a dice pattern will show up on these LEDs, a random number between 1 through 6, and essentially the goal is for the user to get a high number, which is 4, 5, or 6. If that's the case, this will actuate the servo motor over here, which will flip up a sign that says winner on it. And then there is also a buzzer in place right here. And if you get a low number, 1, 2, or 3, it will activate this buzzer, making an annoying noise, which everyone hates. And yeah. Okay, so here is a demonstration of my project. Over here, we have our processing display up. And essentially on the left-hand side, it will tell you the number that you rolled, how many wins you have and how many losses, wins being high numbers that you roll, a 4, 5, or a 6, and losses being low numbers that you roll, a 1, 2, or a 3. So let's look at it in real time. So right now we rolled a 1, and that's a loss. Rolled a 2, another loss. Another 3, another loss. Another 1, another loss. And then we got a winner over here, rolling a 5. Let's try it again. Another loss at a 2. Another win with a 6.
Okay, so now taking a brief look into the Arduino code. First, we have a few functions that I created. So I made a move servo function, which was similar to our lab, where instead of using the servo.h library, we use PWM signals to manually send a signal to actuate our servo motor. And another thing is I have a function called simulate dice roll, which essentially actuates the LEDs in some sort of random pattern, these 7 LEDs, so that it simulates like a shaking effect. And then after that's done, it will randomly generate a value between 1 and 6, and that will show up on the LEDs and actuate in the LED patterns as listed in this 2D array right here. And these are the corresponding dice values, and these are the LEDs that will actuate for it. And then from all of this, there's also a buzzer that will buzz when a value is a low number. If the dice value is greater than or equal to 4, it will move the servo motor 90 degrees to flip up that winner sign. And then we have serial begin to initialize the serial communications with processing. And then this will all get sent via the serial print ln command, which will send the dice value to processing so that it can be visualized in the processing software. Now taking a look at the processing code, there's a few variables. So you have dice value, essentially initializing that dice value variable that we are reading in from the Arduino. And then we have a variable for wins and losses. So essentially this whole processing interface will display in real time the LEDs that are actuated and the corresponding dice pattern in real time onto the dice right here. And then it will track how many wins you have and how many losses you have, as well as what number you currently just rolled. So right now I just rolled a 4, and then right now I just rolled a 1. And there's a bunch of if and else if statements for each dice value to draw the correct dot in. And then there is a if statement down here. If the dice value is greater than 4, it will keep compounding and iterating the win count, as well as if the dice value is less than 4, then it will keep evaluating and iterating for losses.
So to wrap it up, I'm going to talk about what I learned from this project and how it applied to the principles that were taught in ENME351. The first thing is the integration of electronics and mechanical components, so combining sensors, actuators, LEDs, buzzers, and microcontroller programming to create an interactive system. Another thing is I learned a bit about control systems on a very basic scale using pulse width modulation control to actuate a servo motor, and using sensor inputs like a button to produce real-time responses. Another thing is different types of communications. So I'm showcasing some sort of data exchange between hardware, which is the Arduino, and some software like processing via serial communication. And from this, I learned how you can exchange and communicate these types of data to enable visualization and other additional functionalities. And through this whole process, I learned a great deal about designing a system on my own and debugging it and trying to optimize its performance. So thank you for tuning in, and until next time.